Hello everyone. In this session of telescoping series, I'll be discussing those types of sums which cannot be covered by the concept we have discussed in past two sessions. You must remember sum over there. This is very important before we start today's problems to solve, because T1, T2, all these things you write. It is T1 is T2 minus T1. T2 is, I just remind you once more, it is T3 minus T2. This way if you go till nth term, Tn is, or okay, we write this one as telescoping series. Several terms get cancelled, sometimes only the first and the last, or the second last and the second last term exist this manner. But we have mainly discussed two types of sums where the product of terms in a term of the series or product of numbers in a series, they were forming AP and those first terms were in AP. Let me remind you what we have done in last two sessions in brief. We have seen this kind of problem where this series of terms in the denominator, it is actually product of three numbers, those three numbers in AP, and the first term, these 1, 4, 7, these are the first terms in the product, first member of each product are in AP, 1, 4, 7. And they are in the same AP which is given here. This I told you repeatedly in the last session. Similarly, when product of terms given, there also the first terms will be in AP and they are in the AP which is same as the given AP, like 1, 2, 3, 4, 5. Here it is 1, 4, 7, 10, 13 and these first terms also in AP. But today's class, I'll be discussing the type of sum where you don't find the first term there in AP but not in the same AP as in the given term. Like given term, see, it is given in this product 1, 5, 9 there in AP, 2, 6, 10 there in AP, 3, 7, 11 there in AP, but these first terms are not in the same AP. They are also in AP but not in the same AP. Similarly, for the second problem, 1, 2, 3, they are in AP, but here the series is given in such a manner that this 1, 2, 3 not in the same AP as given here, 1, 3, 2 square, 3 square, like this. Bit complicated. The method for this, what we have used, was the general term into when product of terms in arithmetic progression, the denominator given, we have rewritten the general term in this form, last factor minus first factor by their difference. And then we are able to express each term as difference of two terms and then finally we derive the sum. Now for this one, again the same manner, we are able to express each term as the difference of two terms and you can find. Just you have to remember that the general term is general term multiplied by extra factor on right side of the last term minus extra factor on left side of the first factor. Now, the kind of series we are going to solve here today, this method will be useful but after finding the general term and expressing those terms in a particular form, where, just for example, I remind you what I did in the last class, that we have written the nth term Tn as un plus 1 minus un in this form. What are the, to find when you have expressed the nth term in this form, we have T1 for n equal to 1, u2 minus u1. T2 is, I just remind you because our calculation will be easier if you remember the sum of these terms here. Tn is what? it is un plus 1 minus un, and when you are finding Sn as sigma Tn, I mean sum of these terms, finally it is un plus 1 minus u1. You remember that un plus 1, what you have written here, in the answer you will get that minus putting n equal to 1 at the end. This method I showed you in several problems in the last video. Okay, you can go through it once more before you start today's class. What I want to tell you, for these kind of sums where 1, 5, 9, 2, 6, 10, they are forming AP, but these first terms are not in the same AP. We could have used the same method which I have discussed already. But here what to do, when you are going to find the sum of this series, we will be writing, we are answering say number 1. We will be writing the nth term as before. Tn is what? Nth term of 1, 2, 3, all of you know n. This multiplied by this is n plus 4. I mean, yeah, 1 plus 4 is 5, you know, 2 plus 4 is 6. So second term we are writing n plus 4, and this one is n plus 8. Okay. To find the sum of this series, nth term, finding nth term is important. But this you can never express in the form that un plus 1 minus un or opposite to it. Then what to do? You must think that we can express this one in the form of un plus 1 minus un, but not this whole thing in general. If we have consecutive terms in the product like n plus 1, then we can easily use the method we have discussed in the last class. That is modifying the last term, writing the factor on right side, minus writing the factor on left side of the left extreme term, divided by difference. You can find the sum easily. But here, this nth term as a whole, we cannot express un plus 1 minus un. So our effort will be to express the nth term in the form of product of these consecutive terms like n plus 1, n plus 2, like this. Okay. So we'll try to get this one here first. So our first approach on this sum will be to express this nth term as the product of these consecutive terms, maybe 2, maybe 3 terms like n plus 1, n plus 2. We'll try it without any fixed method, but later on if sums becomes complicated, we'll definitely use a different method to express it as terms like this. So let us do it first. Let us try it first without following any method, any fixed method. So we are writing this one as n plus 1. We need n plus 1 plus 3. We need n plus 2 also. We write n plus 2 plus 6. Now let's see what happens. It is n plus 1 plus 3n multiplied by n plus 2 plus 6. Splitting this, you must do it carefully because we need n plus 1, n plus 2. Same time we need n plus 1, but we don't need n plus 2. But in the product, obviously we'll get a term like that. If we try to write it as n, if we open the bracket, n plus 1, n plus 2 plus 6n into n plus 1, we need it, plus 3n into n plus 2. 3n into n plus 2, again it will create huge problem for us to express it in the form un plus 1 minus un. So what we'll do here, We'll write 3n into n plus 2 definitely, but that n plus 2 will be n plus 1 plus 1. Then it's fine. We needed n plus 1, n plus 2, and this is 9 in n plus 1, this plus 3n. Okay. There is another term. We forgot to write 6 into 3n, that is 18n. 18n also there. Now tn is expressed like this. Sum of these n terms, n plus 2, 9n into n plus 1 plus 21n. So of course when you write Sn, this is going to be sigma Tn. This is nothing but sigma n plus 1, n plus 2 plus 9 sigma n plus 1 plus 21 sigma n. You all can see that this kind of sum we have done in the previous session, where we can easily express this one in the form un plus 1 and un this one also, and this one is just sum of first n natural numbers. So our effort will be to calculate this sum. Suppose you are taking this one S1, this one S2, this one S3. S1 going to be what? This you write for S1 nth term is just say T1, Tn1. We are writing this form n plus 1, n plus 2. What is the method of writing this nth term of the series? Last class I told you. You write Tn1 for first series nth term. What you will do here? You will write this one as this term as it is, like n plus 1, n plus 2. Now we take one term extra on right side. What is that? It is n plus 3. They must be in AP, in the same AP. Here before it, it is n minus 1. So we write the term next. We did many sums based on it in the last session. You go through once if you don't remember. N plus 3 within bracket, the next one, and n minus 1 before it within bracket. But this will make a problem if you don't divide by 4. You all understand? Remember the method? So this you can write n. I just doing details once more for you. N plus 2, n plus 3 by 4 minus n minus 1 n plus 1 n plus 2, that divided by 4. Okay. So what it is going to be? Here is this you can write. First one, if you write un plus 1, this is definitely un, isn't it? And what is the sum if the series expressed in this form? S1 will be sigma Tn1. This is sigma un plus 1 minus un. Just I showed you, this is nothing but un plus 1 minus u1. Okay. So what is un plus 1? This product, it is nothing but n plus 1, n plus 2, n plus 3, that divided by 4. N equal to 1 is 0. So you simplify, you get S1 in this form. The first sum is done. In this Sn, the first term S1, first sum S1 is done. Now we are going to find sum of this part, like S2. How to find S2 here? S2 going to be this, if we consider this part only, n into n plus 1 part only, sigma of this you can express easily in the form of what? The term next to it is what? N plus 2. Sum before n is what? N minus 1. And this result divided by 3. This I explained last class. So what is the sum here? Like First one, if you write, it is 1/3 sigma n plus 1 n plus 2. This minus sigma n minus 1 n plus 1. Isn't it? So this is definitely un. If you take this one as un, which one? This one as un plus 1, then this one going to be un. What is the sum of this series? Whenever you have expressed in this form, even today's session in the beginning I told you, sum will be what? This un plus 1, n plus 1, n plus 2 as it is, minus, put n equal to 1 at the end, u1, that is 0 again. So this sum, finally you got Sn equal to what? S1. S1 you got this sum, n plus 1, n plus 2, n plus 3 by 4, this plus 9 by 3, n plus 1, n plus 2, plus 20, this sigma n, all of you know, you can use the method also, n plus 1 by 2, that method only, that is the sum next, the sum before. That is, in this case, how will you write the Tn3 nth term? If you don't remember any formula, then also, this is the greatest advantage of this method. You just remember the technique. Even you know the formula, the technique is of great help. Tn minus 3, how do you write? The nth term as before. Then what will you do? The term next, n plus 1, minus the sum before, n minus 1. What is the difference? By 2. See, it is coming like that. Okay? It will be like that only. So sum you can get nicely by using this form also. And here also this product, n into n plus 1 is un plus 1, n into n minus 1 is un, and find the sum. If you don't remember even sum of this arithmetic progression, where first n natural numbers are added. I hope all of you have understood. Let us go for next one. For this second problem, it will not be very easy to express it in the form of n plus 1, n plus 2 like that. So if you can do it by the manipulation we did for the previous sum, it's fine. But if you can't do, then there is a method to express this one in parts of n plus 1, n plus 2. That I'll discuss step by step. So answering the second problem, we are writing the nth term first. 1, 2, 3, their nth term is n. Nth term of 3, 4, 5 is n plus 2. And this one square. You all understand? N plus 1 whole square. For 2, it is 2, 3, 5. Just let me. So this will be actually 4 square. Okay. So n plus 1 is okay because this is 2, this is 3, this is 4. So by getting this one as Tn, we write n in the form n plus 1 you can write. But there will be a problem in writing this n plus 1. So writing n plus 1 or n plus 2 form will give you trouble. Because here expressing the second term is n plus 1 whole square in the form of n plus 3, not so easy. So you'll try to express it in alternative method without expressing it like the previous sum. Sums are easy, then you can express the way I told you. Otherwise, you write Tn in the form a plus bn plus c n into n plus 1 plus d n plus 1 n plus 2 plus e n plus 1 n plus 2 n plus 3. We will not proceed more because it is a 4th degree polynomial, so we need this only. But why we are doing so? Because our aim is to express each term in the form of un plus 1 minus un. that telescoping series where you can express each term as difference. If we can find the value of A, B, C, D by any method, then we can find the sum of this series because Tn only written this manner. So let us try to find the values of A, B, C, D. You go on putting the values. What value we are going to substitute? Let us put n equal to 0 first. This Tn is actually what? That n into n plus 2 into n plus 1 whole square. For n equal to 0, what will you get? A plus the remaining terms are zeros only. N is there everywhere. This will be equal to 0. Therefore, A0. Now put n equal to minus 1. If you put n equal to minus 1, this left side A is 0. So B into minus 1 plus remaining terms are all 0. Equal to right hand side, if you put n equal to minus 1, 0, this implies B is also equal to 0. Alright. Now for finding the value of C, put n equal to minus 2. So if you put n equal to minus 2, C into minus 2 into minus 1 will be remaining. This portion 0, this one 0, minus 2 also 0. Therefore, so A, B, C, these three factors equal to 0. You have to find the value of D. You can put one value over there. Put n equal to minus 3. If you put n equal to minus 3, here it is going to be this part 0, 0, 0, all we got. D into minus 3, minus 2, minus 1. E will be 0. E is coefficient will be 0. So it will be minus 3, minus 1 into 4. Therefore, this part is what? D into minus 6. So D into, we have taken D equal to minus 2 over there. N equal to minus 3 over there. So it will be minus 3. Minus 3, minus 1 and minus 3 plus 1 whole square. I hope all of you have understood. D's value going to be minus 12 by, minus 6. So D is minus 2. How to find D? You put arbitrary value over there. Okay, anything you can put. This is an identity. So to get the value of E, what we are going to do there, we are going to put, we did not put n equal to 1. So let us put n equal to 1 over there. Put n equal to 1. All these are 0, only D is there. Minus 2, 1, 2, 3. Because D we got minus 2. And put n equal to 1 over there. This plus E. Plus E we have to find. So E into 1, 2, 3, 4. And this thing equal to, put n equal to 1 over there on the right side. This is going to be 1 into 3 into 4. Therefore, 24E equal to 12 plus 12. So E is equal to 24 by 24. This is 1. Finished. If we can express Tn in the form of n plus 1, n plus 2, n plus, then everything is done. What's the value of D we got? Minus 2 and E1 rest is equal to 0. So this Tn now we can write as minus 2 n plus 1, n plus 2. This plus E. E's value is 1. So 1 into n plus 1, n plus 2, n plus 3. You all understand? So Tn we got here. Finding Sn, just it will take 2 minutes to solve for you because you know the method. For this complicated series even, you got Tn as this form, minus 2 n plus 1 n plus 2 plus n plus 1 n plus 2 n plus 3. This is your task to find this sum now, because this by the previous method you can express in the form un plus 1 minus un, and this one also, because product of 4 consecutive terms are there, we can easily do it, isn't it? And then find the sum, just sum of these n terms and sum of these n terms. Okay, so I'm not going to do it now. I'm more interested to show you another one. This method I hope all of you have understood. You must try and write your answer in the comment box. I'll check it. I'll let you know. Finding the sum of the series where nth term given in this, nth term given in this form, then up to nth term, how to find the sum. I'm not asking infinite series sum. Obviously, it is going to be infinity then. But here, we will find the sum up to n terms for this series. How to start? See, the concept already we got. By using it, we can find the sum easily here. Why? Because we'll try to express this one as un plus 1 minus un form. But is it possible? If nth term given, can I ever express it in the form n plus 1 whole square plus n plus 1 into 2 to the power n plus 1 minus that? May not be that form. May not be exactly for n what you get here, minus for n minus 1 you get here. But we will be able to express, because the difference between 2 to the power n and 2 to the power n plus 1 is a factor 2. We remember this in our mind. So if we write the series, actually it's going to be that 1 square, that is 2 into. So if you put the values here, n equal to 1, 2, 3, the series is like this. So for this series, again we are going to express this one as difference of two terms. How to? This we write, let Tn, n square plus n 2 to the power n equal to an square bn plus c 2 to the power n minus 1 whole square we can write n minus 1 or n plus 1 as you like. If you want to say that no, I will write in the form of n plus 1, you can do it, no problem. But this is also valid. So what is our plan? We want to express, if we write this one as un, then this is going to be un minus 1. And when Sn is summation of this thing, this we have seen in the first video, that how to write the sum here. It will be for n equal to 1, u1 minus u0 plus u2 minus u1 plus this way it is un minus 1. All these get cancelled. So this first term with the last term of the next series. So till this all get cancelled. The sum will be un minus u0. Okay. We did sums based on it. I hope all of you remember it. So our aim is to express the given nth term in this form, an square bn plus c to the power n. This is just a type. As it is power given, that 2 to the power n, we are supposed to do this sign. Now can you get the values of a, b, c from this consideration? This time I am going to show you this sum not by putting values, on comparison, because this method is also very useful. So what you will do here first, you will divide both sides by dividing by 2 to the power n minus 1. See, 2 to the power n is there, dividing by 2 to the power n minus 1. What will you get? N square plus n equal to, if we divide by 2 to the power n minus 1, here also 2 will be remaining, an square bn plus c minus an minus 1 whole square bn minus 1 plus c. Now this is an identity. We can compare two sides. Just write 2n square plus n equal to 2 into an square bn plus c. My aim is to compare the coefficient of like terms from two sides, bn minus 1 plus c. Okay, but minus sign before this and minus sign before this also. Okay, so now what you will do, n square has coefficient 2a here and minus a here, 2a minus a n square. Okay, and n has coefficient n, coefficient of n, this is 2b, n is minus minus plus 2a, again b, n, and then constant term plus 2c minus a plus b minus c. I think all of you have understood. Just check it once more. This will not be plus b, this is minus b over there. So what you are going there, what you are getting there, you write this thing as 2 into n square plus n square plus b plus 2an plus, compare the coefficient of like terms, n square to n square. Comparing the coefficient of like terms, we get a equal to 2. So b's value is 2 minus 4. This is minus 2. C minus a plus b equal to 0. So c equal to a minus b. This is 4. Okay. Now we can check that nth term of the series, this series whose nth term given, or we have written this form, can be expressed in the form un and un minus 1. Why? Because a, b and c, all three you got. So what can you write here? N square plus n into 2 to the power n equal to a. A if you put 2n square minus 2n plus 4 into 2 to the power n, this minus a n minus 1 square, that is 2n minus 1 whole square, 2n minus 1 plus 4 whole thing multiplied by 2 to the power n minus 1. Okay. So nth term you have expressed in the form un minus 1. Then what is the sum of this series? Sum of this series is now going to be equal to un minus u0. This is the advantage. Same way, the biggest advantage here, such a huge problem, it is impossible to do by any other method. We can get it by difference method, because this is also kind of telescoping series where terms get cancelled. Only the nth term and the, not nth term, only un and u0 exist. Un and u0 will define. What is un here? It is 2n square. It is given below here. 2n square minus 2n plus 4 into 2 to the power n minus, for n equal to 0, u0 going to be equal to 4 into 2 to the power 0. So this is the sum. 2n square minus 2n plus 4 to the power n minus 4. Okay, this is going to be the answer. So I have tried to explain all different kinds of sums you expect on telescoping series on various competitive exams, including JEE, and then I'll send a practice problem sheet to solve sums from there on telescoping series. Okay, and a form. Thank you.